this next video involves polar coordinates as well, and we're going to take it a step further beyond that and learn how to solve for theta, looking at trig functions in a little bit different light. So we have two pieces to that. And the step that we're going to take with the polar coordinates today is now adding the other quadrants. And so let me show you how that works. If we're given a rectangular coordinate, -√3, 1, let's think through our steps again. I want to find the polar coordinates, which means I need to find the radius and I need to find the angle. And that's how my coordinate is set up. So step number 1 is to find the radius, right? And how do we find r? I hope you're saying Pythagorean theorem, of course. And so let's do that. That means that I'm going to take the negative square root of 3, that whole thing squared, plus 1 squared, and I'm going to solve for c squared. Remember that a negative when it's squared becomes positive, and the square root when I square it basically drops off. So this is actually 3 plus 1 equals c squared. And so that means that c squared equals 4, and rather c equals technically plus or minus 2. Now, step number 2 is to find theta. And when we found theta in the last video, we talked about what you do is you take the coordinate, -√3, 1, and you're going to divide by our radius that we just found of 2. Okay, that's how we're going to do that. We're going to use that 2. And so then I'm going to map this. I should be thinking about my unit circle, right? I should be thinking about what that looks like and think to myself, okay, where is -√3/2, 1/2? That's this angle that's over here. And think, oh, that's the pi/6 angle that's in the second quadrant. So that means that that angle, theta, is 5pi/6. So my answer to this for polar coordinates then would be my radius, which is 2, 5pi/6. All right, now what if they give me the polar coordinates, but I want the rectangular? The only thing that this does is it says, okay, we're going to first start with the angle, and we're going to map that to the unit circle. So once again, we're going to think about that unit circle. We think about where 4pi/3 is, so we know that's down here. And I want to think about what those quadrants are, or what those coordinates are, excuse me, what those coordinates are. And of course, those coordinates are 1/2 and √3/2, but they're both negative, right? And so I already know, ooh, there they are, -1/2, -√3/2. And then the next piece of that, of course, is to scale it up using that radius. So we're going to multiply through by 2, and I would get -1, -√3. So it really doesn't change much by altering into those quadrants. It just basically adds the negatives to it, which certainly can be difficult in and of itself. Where we want to spend most of the time in this video is involving these questions here that you see, where we're solving for theta, and it gives us different scenarios, different possible ways of asking these questions. And so the first one says cosine theta equals 1/2. This question I asked you multiple times in chapter 3 and in later chapters as we were doing different questions. So all I'm asking is, when does that happen? And so from our unit circle, you should have that right in front of you here. You want to look for when does x equal 1/2? And so all that you're doing really is you're looking for, oh, 1/2, and you're going to look up and you're going to look down, and you see on that circle there are 2 different spots that have coordinates that start with 1/2, something, right? This one's of course negative down here, but this one up here is positive. And those coordinates that start with 1/2 are your pi/3. So that would mean that theta would be pi/3, and what's the fourth quadrant one? 5pi/3. And so it becomes easy to see off the chart, doesn't it? All right, how about cosine squared of theta? What are we going to do to that? I hope I hear this resounding square root of the whole thing. But remember that whenever we take the square root, we have to remember plus or minus. So I'm going to use the same unit circle that I used here in the previous question. We don't just want the positive 1/2, we also would want the negative 1/2. And so similarly, I would look here and I would look here. In other words, it wants all of your pi/3 angles, and it becomes kind of obvious what those are just from that unit circle, and you can see how useful that can be, or at least I hope it does. All right, last question. This involves a little bit more detail. Now we've got cosine squared plus cosine. We can't just take the square root. We can't just solve it. What do you notice about these? They both have a cosine. Well done. And if you factor that out, you're left with a cosine theta here plus 1 equals 0. And just like with factoring, just as if this was an x, you're going to set each part equal to 0. You've done these before, right? I just made that look like a theta. I apologize. You're going to set them both equal to 0, and you're going to find out when does cosine, starting out, equal 0. And of course, that basically means when does your x equal 0? And this is when x is 0, so you look up here and you look down here. Oh, that must mean that theta is at pi over 2 and 3 pi over 2. Doesn't that make sense? And how about this one, cosine theta? When does that equal negative 1? So again, when is x negative 1? And that falls ever so nicely over there at pi. And you can see how the unit circle can become a great resource for not just our reference angles of pi over 6, pi over 4, and pi over 3, but also for our graphs that we used to have to look at both, the chart and the graphs. Now we can just use the unit circle for both of them.